Hi friends, so welcome back. Today we are going to start with a new topic called LCM and HCF. So in the competitive world, this LCM and HCF is a very important topic. So in today's session, we are going to deal how to do this LCM and HCF pattern. So I'll show you one PPT presentation kind of thing. In that all the basic parts will be covered how the LCM and HCF has to be found out. Now, shall we start the session? Okay. So today's topic is about LCM and HCF. You know what is a abbreviation of that? What is HCF? Highest common factor. And what is LCM? Lowest common multiple. Okay. Now, in today's session, we'll be dealing with how to do these problems using prime factor tree method. Okay, this is very important, and from the childhood we will be learning about this prime factor method. So in today's session also we'll be seeing what is actually a prime factor method. Okay, and later we'll be solving two problems related to HCF and LCM taking two numbers. So how actually an LCM and HCF is properly done in a real time. Shall we start the session then? Okay. So in this session, you will be learning how to make a prime factor tree. And also, you will be also finding what is a HCF of a two numbers and a LCM of a two numbers. So by the end of the session, you will be able to come out with the prime factor tree method, how to apply a prime factor method, and that is how it is used in a HCF and a LCM concept. Now, so I'll give you a small example. Let us first start with the highest common factor. Okay, so let us take two numbers here. What are those two numbers? 8 and 10. Now, in these two numbers, if you see, what is the biggest number that will go into both? What is the biggest number that divides 8 and also 10? So I have written the answer as 2. If you take 1, yes, 1 is a number which divides 8 and 10. But what do I want? I want the biggest number, because we are finding what? Highest common factor, right? What is highest? The highest which is present in one of the individual, and it has to be common in both of the numbers. So now, what is the highest number? Yes, 1 goes with 8 and 10 also. But is it 1? What is the only number? No. If you take the number 2, even 2 goes with 8 and 2 goes with 10. Right? Yeah. So how much 2 goes with 8? So if you see here, 2 goes in 8 4 times. So if you divide 8 by 2, you are getting the answer as 4. So 2 is exactly divisible by 8. So if you go in a second pattern, 2 goes into 10. So how many times? 5 times. Yes. So 10 divided by 2 will give you 5. So 2 is also going in 10. Now let us take the example 3. If you take the number 3, what is happening? 3 goes with 8? No, it do not go exactly. 4 goes with 8? Yes, 4 goes with 8, sir. 4 goes with 8. Then if 8 by 4 if you do, okay, fine, you will be getting some number. But what about 10? 10 is not going with 4. So whatever a number you are choosing, it has to be a common and it has to go both numbers. So if you take 4, if you take 5, if you take 6, 5 even doesn't go, 6 doesn't go, 7 doesn't go, 8 goes, but it doesn't goes with a 10. So all the numbers are gone. So only number, the biggest number which goes for 8 and 10 is 2. So I can say that there is no bigger number than 2 that goes into both. So it is the biggest factor or highest common factor. Now you come to know how to find the highest common factor. Highest. So highest which is there in both the numbers, it has to be a common. That is called as a factor. So I hope you got what is actually HCF, highest common factor. Now let us go to the other concept called LCM, lowest common multiple. So understand, lowest common multiple. Now let us take the same number. Let us take the same number. The numbers are 8 and 10. Now in these two numbers, we have to find the multiples. From the small classes, we know that what are multiples. What are multiples? Yes, you are right. So when I say what are the multiples of 2, you say 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, etc. etc. Now if I say what are the multiples of 8, what do you write? 8 1s are 8, 8 2s are 16, 24, 32, 40, 48, 56, 64, etc. etc. These are what? 16, 24, 32. These are called what? These are called multiples. Yes. Now I want to find out the multiples of 10 also. So how do I find it? So you know the multiples of 10. 10 1s are 10, 10 2s are 20, 10 3s are 30, 10 4s are 40, 50, 60, 70, 80. So these are the multiples of 10. Now, what do I want? Lowest common multiple. The number should be lowest and it has to be common. In which one it has to be common? I am taking the numbers called 8 and 10 now. In these two numbers, there must be a common multiple. So, if you compare 8 and 10, 16 is not present in 10 series, 24 is not present in 10 series, 32 is not present in 10 series, 40, what about 40? Yes, 40 is present in a 10 series also. Can I say that it is common between what? 8 and 10. So I'll mark a circle. Now what do I want? There might be other numbers also which are common. But what do I want? I want a lowest common multiple. So can I say that? So in this multiples of 8 and 10, what is lowest? 40 is the lowest. Exactly. So we got the answer as the first time they cross it at 40. So the lowest common multiple of these two numbers is 40. Hope you got what is the concept involved in LCM and HCF. Okay. So let us go forward. Let us go forward. An interesting fact I want to share with all people. Finding LCM and HCF using the prime factor tree. But before finding out the prime factor tree method, did you know something? Every number is made from prime numbers multiplied together. Amazing fact. Is it not interesting? Take any number. The numbers are nothing but a sequence of all the prime numbers. If you multiply all the prime numbers, you will be getting one individual number. Is it not an interesting fact? So how that interesting fact will help us to find out a prime factor tree method? Okay, shall we go forward? Okay. So before going forward, let us look at a series. What are prime numbers? What are prime numbers? Number 2, number 3, number 5, number 7, etc. etc. These are some of the examples of prime numbers, the first prime numbers. Okay. So generally, whenever you see the numbers, generally these numbers are very frequently getting appeared. There are many prime numbers, but these are some of the first prime numbers. So what are prime numbers? Yeah. So 1 is a factor of prime number and the number itself. So for the number 2, 1 is a factor and the number itself. For the number 3, 1 is a factor and the number itself. And number 5, 1 is a factor and the number 5 itself. So every prime number will have one factor, which is 1, and the second factor, the number itself. Okay, now let us go forward. Now let us see some exercise, how to solve an HCF and LCM of the numbers 60 and 72. So first, we will go through the prime factor tree method for 60. Okay, what is this prime factor tree? Okay. So we have to find the prime factor for 60 and 72, right? So let us start with the number 60. So I have done a prime factor tree for the number 60. So now in the tree, are you looking at a tree here? Yes. In the tree at the top, I have written the number 60. Now, how the 60 number can be written as? 2 into 30. So 2 into 30 gives you 60. So I'm dividing a 60 number into two parts, which is 2 and 30. If you multiply both numbers, you are getting again 60. Now, let us go in the second level. Are you seeing here? What is the number 2? Yes, it is a prime number. Okay. So the number 60 is a combination of number 2, a prime number and another number. Now let us divide this number again, the number 30. The number 30 is again divided into a prime number 2 and 15, which is coming to 15 into 2 is 30. So can I write it? The number 30 can be divided into 2 and 15. Yes. So amazingly, if you see that the number 30 is also a combination of a prime number, which is 2 and 50. Now there is another number 15 left. So let us again factorize this. So 15 can be written as how? 3 into 5. Now if you observe amazing thing, the prime number, both are prime numbers 3 and 5. So the 15 is a combination of both prime numbers. So that is what I have written here. The number 15 is divided to 3 and 5. So I can say that 60 is all the prime numbers. Can I say that? So if I multiply what? 2 into 2 into 3, 3 into 5. If I multiply all these numbers, what do I get? 60. So if you, amazingly, if you see here, all the numbers are prime numbers. So if you multiply all the prime numbers, you are getting 60 value. Now let us go forward. Let us go forward in identifying how to find out a prime factor for 72. How to do that? Okay, so let us see. 72 can be written as 2 into 36. As in a diagram, you know that at the top, the 72 will be written. So this is written as 2 into 36. So it is nothing but 72 is a combination of 2 into a prime number and another number. So again, 36 can be divided into 2 into 18. So again, 18 is divided into 2 into 9. And again, 9 is divided into 3 into 3. So can I write it? 72 is a prime number which is a combination of 2 into 2 into 2 into 3 into 3. How did I get it? If you see the above one, yes, 2 into 2 into 2 into 3 into 3. If you multiply all these numbers, you are getting again a 72. So I can say that 72 is also a combination of a prime numbers. Now how to find out an HCF? Let us see. So I have drawn a 2 tree diagrams here. Now what is a HCF? Highest common factor, right? Okay, how to find out this? Now let us see what are common here. Okay, the factor 2 is common, which is present in 60, and here 2 is common, which is present in 60 and 72. 3 is common, which is present in 60 and 72. 5 is common? No, you do not find any common. So I can say that 2, 2 and 3. These are the common factors between 60 and 72. So can I say that if I multiply all the numbers which are 2 into 2 into 3, I'll be getting how much? 12. So 12 is the biggest number that goes into both 60 and 70. So it is a highest common factor. Now you understood how with the help of a tree method, we will be able to solve the highest common factor, which is nothing but HCF. Okay, let us go forward. Let us find how to find the LCM. Okay. Now, a very interesting factor. Let us see. The same tree diagram, whatever a tree diagram we have seen here, which is 60 and 72. Okay, these are the two tree diagrams. So if you see here, what is happening? So now my concentration is not on the factors. Are you observing here? Before the HCF concept, my concentration was on a factors. Now my concentration is on a multiples. Did you observe here? So now, interestingly, see here, I cancelled those numbers which are already used in HCF. So whenever you try to do an LCM concept, first try to cancel all the factors which are common. Yes. So I cancelled 2, I cancelled 2, I cancelled 3. All these 3 are common which were used in HCF. Now what are remaining? 30, 15, 5 and the other numbers here. So how to find out an LCM is nothing but. Now, if you take the last factor which is remaining, that is multiplied with the number which is opposite to that. So which is nothing but 72. And in a similar way, you can do it in either way. So what is 5 into 72, which is coming to 360. Now, if you do in other way also, what is the other chart, which is 72, in which what was the remaining factors, which was 2 and 3. So if you multiply both of them with the first number, so you'll be getting 2 into 3 into 60, which is coming to 360. So if you see, both the answers are deriving the same number, which is 360. So I can say that cross multiply top two numbers in an opposite tree. That is the main concept here. So 360 is a LCM of 60 and 72. So this is how the prime factor method can help you to find out LCM and HCF. Now let us see, there is also one more method of finding an LCM with a Venn diagram method. Okay, so let us see that. So as you know that the 60 is nothing but, you can write it in a terms of 5 into 3 into 2 into 2, which is nothing but what? All the prime factors. So you see the diagram. So 60 can be written as 5 into 3 into 2 into 2. And in a similar way, 72 can be written as all the prime numbers multiplied. Right? Now, what I am doing, I am trying to identify what are the common numbers. If you see in this red color, these are what? These are what? These are what? A common numbers present in 60 and 72. So all those common numbers are written in the Venn diagram intersection. So you know that how to draw a Venn diagram here. So in the Venn diagram, this intersection section is a common part between 60 and 72. Now what is remaining? 5 on the left hand side and 2 and 3 on the right hand side. Now what you have to do then? How to find out an LCM then? So if you see that 5 into, what is a common? 2 into 2 into 3. And then what is the next one? 2 into 3, which is coming to 10 into 6 into 6, which is coming to 360. Even this is also one of the method of finding, yes, LCM. Is it not interesting? So every time we are choosing a 5 from here, and whatever a common things are there, we are choosing that and also remaining part. So all the numbers, if you multiply, you will be getting 360. Okay, let us go forward. Let us take one more example in finding a LCM and HCF of some two numbers, 56 and 48. So I think now you are very comfortable in finding how to find out 56 and 48. Okay. So first prime factor method, let us go for 56. Okay. So how 56 can be divided into? 2 into 28. So one is a factor, one is a multiple. Next 2 into 14. 2 into 14, yes. Next 2 into 7. So if you do the diagram, 56 can be divided into 2 into 28, and 28 is further divided into 2 into 14, and 14 is further divided into 2 into 7. So 56 is all a prime numbers. So which is a combination of what? 2 into 2 into 2 into 7. So if you multiply all these numbers, you will be getting a prime number. Prime factor tree for 48. Okay. So there are two numbers, right? So one number is 56, another number is 48. Let us find out a prime factor for tree for 48. So how to find out? 48 can be divided into 2 into 24. 24 can be still divided into 2 into 12. This one further 2 into 6, and this one further 2 into 3. So what are the prime numbers which are involved in the number, which is nothing but 2 into 2 into 2 into 4 2s into 3. So this whole multiply you will be getting a 48. Now, how to find out a HCF? So you know that what are the common factors? Please choose it. I have chosen a 2 and 2 here. I have chosen a 2 and 2 here. I have chosen 2 and 2. Any other number which are common? No. So what is the HCF? Common factor, highest common factor. So which is nothing but 2 into 2 into 2, which is coming to 8. 8 is a HCF. Now let us find out what is LCM. So you know that draw the same diagram. As you know, just cancel the common factors which are encountered in a HCF. Now what is the remaining number? Remaining factor is 7. Now 7 multiply with the counter number, which was 48. So 7 into 48 is 336, which is nothing but LCM. R. You can also do what is the remaining number here, which is 2 into 3. So 2 into 3, which is nothing but a prime factor, it has to be. That number has to be multiplied with the counter number, which is 56. So if you do that, you are getting 336. So what is the LCM of 56 and 48, which is coming to 336. Now, a Venn diagram method, as you already know how to do this. 56 and 48. Please write down all the prime factors of 56, all the prime factors of 48. So how do you do that? Okay, so prime factors, all the common numbers will be written in the intersection area. So number which is remaining will be written on the left hand side, and number which is on a right will be written on the right hand side. So how to find out an LCM? Take the numbers 7 into the common numbers and this number, which is coming to 7 into 222 into 2 into 3, which is remaining number. So if you multiply all these numbers, you are getting answer 336. So this is how you find out an LCM and HCF of any two given numbers. Hope LCM and HCF concept is very clear. So what you have learned in this session? What you have learned? So you have learned how to prepare a prime factor tree. Okay. And you have also learned how to find out an HCF and LCM of two numbers. Okay. So hope you enjoyed this session very comfortably. So now if anybody asks you a question, what is LCM and what is HCF? I think you'll be able to answer that, right? So what is LCM? Least common multiple. So your target should be all the multiples. What is HCF? Highest common factor. So the factors has to be in a row and in that highest. So probably these are one of the easy methods to opt for LCM and HCF for any two numbers. So hope you enjoyed this session. So we'll be again back with a new topic. So till then, thank you very much.